Hello everyone, welcome back to Coding by Jaan. In today's video, we are going to solve a very interesting problem asked in Accenture called the bulb switcher. We will break it down step by step and solve it using Python without using any built-in math function. So let's get started. Here is the problem statement. There are n bulbs that are initially off. You turn on all the bulbs, then you turn off every second bulb. On the third round, you toggle every third bulb, turning on if it's off or turning off if it's on. For ith round, you toggle every I bulb. For nth round, you only toggle the last bulb. And he asked to return the number of bulbs that are on after n rounds. So we have to return the number of bulbs which are in on position after completion of n rounds. Let us take some examples. Here he has given a description picture. He has taken 3 bulbs. In first round, we will switch on the bulbs. In second round, we toggle every second bulb. In third round, we toggle every third bulb. So you can see here, in second round, if we toggle every second bulb, so the second bulb will be off. In third round, we toggle every third bulb. So initially, the third bulb is in on position, but in third round it will be in off position because we toggle every third bulb. Here is the description. You can see here n is 3, means there are 3 bulbs, and output is 1. 1 means after round 3, here only one bulb is in on position. So let us see how to approach this problem. Now here's the important part. A bulb will only remain on if it is toggled an odd number of times. You can check out this example. Here n value is 3. If we take n value 4, then after the round 3, it will look like this. Okay, after round 4, we will have first bulb and fourth bulb in on position. If we take every perfect square, that is 1, 4, 9. Round 1, we toggle every bulbs, that is from off to on position, that is 1. So every bulb here is in on position if n value is 1. So bulb 1 toggled only once, that is from off to on in first round, after first round. And bulb 4 toggled in rounds 1, 2, 4. Here we got odd number of toggle, so it is in on position. After round 9, that is bulb 9, toggled in rounds 1, 3, 9. Here also we got odd number of rounds, 3 rounds. So it is in on position. Similarly, it will happen to 16, 25, 36 and so on. All the perfect square positions are in on position only. Let's dive into Python code. What we have to return here is, we have to return how many perfect squares are available till n value. So we will take on variable count, which stores the number of perfect squares available till n value. We will take one parameter I, that is we will start from 1 because we take n value from 1. We will take on loop while I into I less than or equal to n. I into I, why we are taking squares, perfect squares. So if we get this, we will increment count plus is equal to 1 and I plus is equal to 1. We will return count. In this code, we will having, if it get one perfect square less than 1, then the count will be increase and the I value also increase. Then we will move to the next one. Then I value 2. It will check I into I, that is 2 into 2 less than or equal to n. If it is less than or equal to 1, n, then count will be incremented. So count is 2 here and I plus I will be, in next iteration I will be 3. Until this condition is not true, we will iterate this loop. If this condition is false, then we will simply return our count value. Here count value means the number of perfect squares which are present, which are the number of perfect square in which the bulbs are in on position. So we will get our answer. Let's run this. After running this, you can see here all the text cases are accepted. Let's go and submit now. So we have easily submitted and that's it. We have solved the bulb switcher problem without using any built-in math function. I hope this explanation was clear and helpful. If you like the video, make sure to hit the like button and subscribe to Coding by Jaan for more problem solving content. See you in the next video. Till then, happy coding and take care.